We'll continue on with example 2. Example 2, part A, says we are to solve n over 3 plus 7 equals 22. So let's run through our rules for just a minute here to make sure we have everything we're supposed to have. We are supposed to have variables on the left of the equal sign, and indeed n is not only to the left of the equal sign, but it's also the first thing that's presented to us. We're also supposed to have numbers off to the right, and we do have one number off to the right, 22. But both the 3 and the 7 are then going to have to move because they're numbers and they also belong on that right side. Now what they're talking about there in the introduction is what we've already talked about, the order to move things. In this case, 3 is directly connected to the n by division. And if you remember, the rule that we added for two-step equations says the thing that's directly connected to the variable is last to move. So 3 is going to be the last to move, 7 is then going to be the first thing to move. If you need to think of it a different way, think of reversing order of subtractions, because that's really what we're doing. Instead of starting with parentheses and then exponents and then multiply, divide, and add, subtract, we start at the bottom. We start with add, subtract, then we do multiply, divide, then we'd go back up and take care of any exponents and roots and things like that. So, knowing that 7 is going to move first, let's move 7 to the opposite side by doing the opposite, because that's what we do. Since 7 has an addition sign in front of it, I'm going to do the opposite, which is to subtract 7 from both sides. So I have n over 3 here, and 22 minus 7, which is 15. Okay, so now this looks a lot like just a basic one-step equation. We're dividing by 3 here, which I have to undo because I'm sending that number off to the right side. Well, remember, when I move it to the opposite side, I do the opposite. So I'm going to multiply both sides by 3, which is what they're showing you in this line right here. Over on this left side, the divide by 3, multiply by 3 cancels each other out, just like the minus 7 and the plus 7 did here, leaving me just n, which is what I want, and 3 times 15 here, which is 45. And that is also the final solution. Again, we can check that by plugging it back in for n. 45 divided by 3 is 15. 15 plus 7 is 22. Since the other side says 22, we know we did this correctly. Remember, when you're checking, make sure you apply the order of operations. Here, indeed, now they are showing you that check that, as I just presented to you, changing n into 45, doing 45 divided by 3, which is 15, and then adding the 7, which gives me 22. Let's go ahead and take a look at the B question for this example. The B question says y minus 4 over 3 is equal to 9. Now, this one is a little bit of a different question, so let me show you what to do here, because some people might be stuck just looking at this because it just doesn't look like some of the other questions we've dealt with. What's probably going to be easiest to do here is to think of this as two fractions set to equal to each other. And the way we can do that is by making 9 into 9 over 1. Of course, you know that the fraction 9 over 1, 9 divided by 1 is really what that would mean, is the same thing as 9 because 9 divided by 1 is 9. Well, when you have two fractions set equal to each other, what you now have is a proportion. And of course, you know you solve a proportion by doing every middle schooler's favorite thing, cross multiplication. So what I'm going to do at this point is I'm going to multiply the diagonals together. So I'm going to take y minus 4 and multiply it by 1, and then I'm also going to take 3 and multiply it by 9. Now, some people might say, well, y minus 4 times 1, that doesn't sound like a lot of fun. Well, realize we're just multiplying by 1 there. Multiplying by 1 isn't going to change anything. So when I take y minus 4 and multiply by 1, the result is just y minus 4. And on the other diagonal, I end up with 9 times 3, which is 27, which, skipping a few steps down here, is where we end up right here, just in a slightly different form. The only way that problem would be more complicated, and could be a whole lot trickier really, is if the 9 had started off as a different fraction altogether. Let's say it was 9 over 2. When I took 2 and multiplied it by y minus 4, then I would have to use distributive property, making sure I carry 2 through to the y and 2 through to the 4. But since it's 1 doesn't change anything with multiplication, so y minus 4 times 1 is just y minus 4. So now we can solve this, and this really isn't even a two-step equation at this point. There's nothing in front of y to make this different. We just have to get the 4 kicked out of the way. We know we want our variable on our left and the lonesome number on the right. 27 is already on the right, but 4 needs to join it. So we're going to move it to the opposite side by doing the opposite. The opposite of subtracting 4 being adding 4 is why they're showing they're adding 4 to both sides, and y equals 31. Again, we can check. We can do 31 minus 4, which is 27, and 27 divided by 3 is indeed 9. Let's conclude by looking at the check it out examples. As you can see, question 1 here is very similar to the earlier presented story problem about fixing a car. It's just that the numbers are a little bit different this time. So let's see if you can take what we saw in that example and apply it here with these different numbers. The mechanic's bill to repair your car was $850. So the bill is $850. The mechanic charges $35 an hour for labor. $35 an hour for labor. And the parts that were used cost $275. Parts at $275. How many hours did the mechanic work on your car? So the total bill, as we learned in the very first sentence, adds up to $850. There are 2 components that make that $850. The parts, no matter how many hours were spent on the car, are $275. The labor is $35 an hour. So if he worked 1 hour, it would be 35 times 1. 2 hours would be 35 times 2. 3 hours would be 35 times 3. And we could sit there and guess and check all we want, but what's probably easiest is if we put this into equation form. Since we don't know how many hours of labor we're actually working here, that's what we're figuring out, we're going to write 35 times h. H is the mystery. That's what we're going to solve for here. And as you can see, what's nice about the way I wrote it compared to the earlier question is I wrote it so that the variable was on the left side. If you remember when we looked at that question earlier, the variable was on the right side and I did a flip right away. I saved myself that step of work by just writing it so that the variable is on the left. Okay, so since we have our variable on the left, that's good, and a number over here on the right, that would also be in proper location, but 35 and 275 both have to travel here now. Remember, the thing that's directly connected to the variable, 35 in this case, is going to be the last thing to go. So 275 is going to be the first thing to go. Remember, when I want to move something to the opposite side, which is what I'm doing here, I'm doing the opposite. Since 275 has an addition sign in front of it, the opposite is going to be to subtract. So I'm going to subtract 275 all the way across to begin. And when I do that, these 275s cancel out, and it's going to leave me 35h equals 575. And all of a sudden, a question that looked rather large, not just written large, but actually long, is now actually a basic one-step equation. We undo a multiplication equation, as you already know, by dividing. So now, because I want to get h by itself, I got to get rid of this 35. That's what I'm going to divide out, 35. The 35s cancel each other out and leave me h. 575 divided by 35 will yield my result, and when I take 575 and divide it by 35, I get 16.428, which, as you can see, they've rounded to just 16.4. So the mechanic worked approximately 16.4 hours on our car. Now we'll look at number 2, n over 4 plus 5 equals 29. Now, this is a little bit different than that proportion question we saw earlier, because remember, the entire left side was a fraction. And here, the only thing that shows up as a fraction is the n over 4 part. And so that's why it's good for us to look at this question, because it is a little bit different. So we're going to say to ourselves, variables on the left, n, which is proper, and numbers on the right, 29, which would also be proper. So the two things we know we want to move here are 4 and 5. Well, we know that the thing that's directly connected to the variable, this time the 4, connected by division, is the last thing to go, which means 5 is going to have to be the first thing to go. So, remember, when I want to move something to the opposite side, I do the opposite, so I'm going to subtract 5 all the way across here. And when I subtract 5 here, of course, these 5s will cancel each other out, and will leave me n over 4 equals 24. So the equation now says what number divided by 4 is 24. Well, remember, I'm solving for n here, so now I want to send the 4 over to the other side as well, because that's how I'm going to get n all by itself on the left side, which is what I'm solving. So how am I going to do that? Well, again, do the opposite. So I'm going to then multiply both sides by 4 to make the dividing by 4, multiplying by 4 cancel each other out. And when I do that, that gives me 24 times 4, which is 96. And indeed, 96 divided by 4 plus 5 is indeed 29. 96 divided by 4 is 24. 24 plus 5 is 29. The left side equals the right side. The equation's check.